Howdy folks, Mr. K here with a online lesson about the basics of the periodic table. So let's take a look at this table. A lot of stuff going on in here, way more than I'm going to talk about in this video, but I want to cover some just basic things. So you notice the periodic table is designed in a grid fashion. We have columns going down and rows going across, but in the periodic table, we don't call them columns and rows. Columns are referred to as groups in the periodic table. And rows, like for example this row down here, are called periods. Now the periodic table is arranged in groups and periods for a very specific reason. It's because it's sort of like when you go to the grocery store, you find things that are similar within an aisle, the grocery store. All like the bread products are in a bread aisle. All the baking supplies are in a baking aisle. It's the same way with the periodic table. Groups have the elements, remember groups are vertical up and down. Every element in the same group has similar chemical properties. Meaning that they react nearly identically because they have the same electron structure. Periods, remember a period is a row going side to side. Everything on the same period has electrons in the same energy level. Now, we haven't talked about energy levels yet. That will come later. The most important thing to remember are the fact that groups are arranged so because every element in the same column or group has similar chemical properties. Now, let's take a look at a close-up of one of these blocks from the periodic table. Here's oxygen's block. So there's several things to notice. First thing is we usually have a single number at the top. That's called the atomic number. The periodic table is organized by the atomic number. Oxygen is in the 8th spot because its atomic number is 8. We'll talk about later where this atomic number comes from, but a clue, it's the number of protons that an atom has. Below the atomic number is usually a symbol of some kind. This is the chemical symbol or the shorthand version of that element. Oxygen's chemical symbol is an O, and usually written below it is the full name of the element. And below that is usually a number that's a decimal. This is the atomic mass. Remember, the periodic table is organized based on the atomic number, the one that we use. The original table was organized by a man named Mendeleev, and he based it on the atomic mass. But it wasn't a very effective table. We found when we organized it by the atomic number, as done by a man named Moseley, the groups and the periods lined up in a much more sensible fashion, giving us groups where every element within the same group has a similar chemical property. Just remember, the first table was done by Mendeleev, and it was based on atomic mass. Our current table was done by Moseley, and it's based on the atomic number. There's more organization, though, than just groups, columns, and periods, rows. There's chemical families, and they're all based around there's a special little stair step in the middle of the periodic table. I'm going to draw it in on this one. There's a little set of stairs going down right here. And this gives rise to the major chemical families within the periodic table. So, the first major type of group is the metals. You know metals, things that conduct electricity are hard and shiny. Everything to the left of the stair step is a metal. Lithium, beryllium, these over here. Every element in all of these groups over here are metals. Everything to the right of the stair step are non-metals. They're the opposite of metals. They do not conduct electricity. They're dull. They're kind of brittle. And then there's a special third group, those that actually sit on the line. The things that sit on the line if it touches the line, these are another special group, and they're halfway in between. They're called metalloids. The things I highlighted in blue there. So metals are on the left side of the table. Non-metals are on the right side of the table. And metalloids, they're halfway between metals and non-metals. They have some metal properties and some non-metal. They sit on a stair step between them. So we have those general groups, metals on the left, non-metals on the right. Well, there's an even more detailed grouping, and it's based on what column, or sometimes group of columns, chemicals fall in. So, working from the left to the right, the very first group on the periodic table, group 1 or group 1A, are called the alkali metals. They are very reactive. They're very reactive metals. If you put any of these metals in water, it will make an explosion. You do not mess around with these. They're so reactive you don't find them alone in nature. They usually have to be bonded to something else to calm them down. So on the periodic table, I'm talking about these elements on this side right here. These are the alkali metals. The next group to the right of the table, group 2A, these elements right here, they are not as reactive as the alkali metals, but they're still pretty reactive. Their name is the alkaline earth metals. So alkaline earth metals in group 2A. Remember, these things are put in groups because they have similar chemical properties. Every column, the elements have similar chemical properties. So they are not as reactive as alkali earth, but they're still pretty reactive. Moving further to the right, we get into a large stretch. And they're called, these are, typical metals that you see in here. We got copper, we got gold and silver and platinum. These are called the transition metals. They transition us from the extremely reactive alkali metals to the not so reactive metalloids and nonmetals. So they're the transition, they're the bridge of the periodic table. These are the transition metals right here. Now, there's also group names for the next right set, but we kind of group them all together. So remember I said that everything straddling that line in the middle, this stair step line, this is all metalloids. So everything within this group is just its metalloid group. And then to the right of the metalloids are the nonmetals. All of these, even these over here, these are all nonmetals. There's only one special nonmetal group, and that's this group right here, called the halogens. Halogens contain things like chlorine and fluorine. They are their own special group because the halogens are the most reactive nonmetals. Yep, group 7A, the second to last group on the periodic table on the right side, are the halogens. Very reactive nonmetals. Remember, alkali earth, the leftmost column, most reactive metals. Most reactive nonmetals are the second to last group on the right, the one that starts with fluorine at the top. But then the very, very rightmost group of the periodic table are called the noble gases, and they're called noble gases because they're very unreactive. So, to sum it up, I know that was a lot. Periodic table is organized by atomic number. This was done by a man named Moseley. The periodic table, each element is given an atomic number, a symbol, a name, and atomic mass. There are major groups within the periodic table. The metals to the left, the nonmetals on the stair step, and the metalloids on the stair step, and the nonmetals on the far right. Remember, left to right, you go metal, metalloid, nonmetal. That's the basic gist of it, folks. I'll see you in class.